Okay, we're going to do the first section 7.1 and part of 7.2 together here just because they kind of flow in, and the first part is fairly short, quick, easy review of absolute value. It says absolute value is how many jumps the number is from 0. Stated another way, it is the distance from 0 on the number line regardless of direction. Distances are always positive values. So 3 is 3 jumps from 0, so the absolute value of 3, or this is the way we write it, 3 with the bars around it, is 3. Negative 3 then is also 3 jumps from 0, so the absolute value of negative 3 is 3. So if the absolute value of x is equal to 3, then we could have been, then x, could have been a negative 3 or a positive 3. So for every absolute value solution, there's a positive and negative possibility. So it's similar to squaring and square rooting. When you square root a value, there is a positive and a negative solution to that. So the only thing you have to really remember with absolute value is that it's measuring a distance. How far is something from 0? So that is why it's our value that it equals is always going to be a positive number. So it says evaluate. Absolute value of 5, well, that's just 5. Absolute value of negative 7, so that's asking how many spots away from 0 is negative 7. What's 7? Negative 0.34, absolute value of that is 0.34. Works the same for fractions. 5 over 6, absolute value of that is just 5 over 6. Absolute value of negative 6 3/8 is just 6 3/8. Now what you have to be careful of is when you have the a negative sign outside the absolute value. So the absolute value of negative 1.2, or negative absolute value of 1.2, is actually negative 1.2. The negative sign has to be in the absolute value sign to turn into that positive distance. So example B says, what are the possible values of x? So what it's asking is, what could be inside that absolute value x that has a distance of 6 from 0? Well, positive 6 has a distance of 6 from 0, but so does negative 6, because it doesn't matter which side of 0 it is, it's still 6 jumps this way, or 6 jumps that way. Absolute value of x is equal to negative 9.7, so that means that x is equal to plus or minus 9.7. Absolute value of x is equal to negative 2. There's no solution to that because you can't have negative jumps from 0. Remember, it's measuring a distance, so this is a no solution. Not to be mixed up with this example up here, where I was put a negative and I was given a value already. We don't have a value for x, so there's no way that it can be a negative 2. Just like when we were looking at square roots in 2 units ago, when we did square root of x is equal to, say, negative 2, we couldn't, there was no solution for that because there's nothing we could put in that square root value to give us a negative answer. So the next example says, write the real numbers in order from least to greatest. So what you want to do is take off the absolute value signs and then put them back in order that they're given. Now what you want to do also is, since we have decimal values in here, if there are any questions that aren't decimal, we're going to put them into decimal form. So the absolute value of 3.5 is just 3.5. Negative 2 has no absolute value, so that's just a negative 2. Negative 5.75 is in the absolute value, so it would just be 5.75. 1.05 stays the same. Negative 13 over 4 is the same as 3.25, and since it's in the absolute value, we drop that negative. Absolute value of negative 0.5 is 0.5. Negative 1.25 has no absolute value sign, and then negative 3 1/3, absolute value of that is the same as 3.25 33333 repeating. Okay, so then the next thing you want to do is take a look at, so what is the smallest value that I have up there? Well, that's going to be -2. So after -2, the only other negative I have is -1.25. Okay, I don't have a 0, but I have 0.5, and I need to write that in my absolute value sign. Remember, just like the radicals, we put them back into their original form. So -0, absolute value of -0.5. After that, we have 1.05. 1.05 didn't have the absolute value sign. Then the next biggest one is at 3.25, which was -13/4. Then comes my 3.3, so that's -3 1/3, absolute value of that. Then 3.5, so absolute value of 3.5, and then my last value was the 5.75, which was -5.75, or absolute value of that. You have to be careful when you're writing your absolute value signs in that you make them bigger than your ones, so that you know it's not 11, or that it's not looked as the first digit in your number. So the next part says absolute values symbols should be treated in the same manner as brackets when applying order of operations. So BEDMAS applies to this. You always do your multiplication, or, well, exponents, then multiplication and division, and then addition and subtraction. So -4, absolute value of -4, that's equal to 4, minus absolute value of -3 is 3, so my answer is 1. So order of operations, if I'm thinking of my absolute value signs as brackets, that means this is in a bracket. And if it helps you underline the steps that you're doing. So this is 2 minus 3 times the absolute value of -12 plus 8. So you have to do what's inside that bracket first. That means I have absolute value of -4. So I have 2 minus 3. The absolute value of -4 is just 4. So 2 minus 12. So my answer is a -10. You have to be careful, because what happens is people want to distribute this 3 to both terms. Not necessarily wrong, but it can change your value, so you don't want to do that. You always want to do your order of operations first. So example C. I have my absolute value sign, so I take a look inside there. The first thing I have is a bracket of 5 minus 7 to the power of 2, so I'm going to do that first. -2, absolute value, -2. 5 minus 7 is -2. -2 squared is 4, so I'm doing that in one step. Plus 6, absolute value sign. So I have -2 times the absolute value of -2 times 4 is -8, plus 6 is -2. So this is -2 times 2, so my answer is -4. So when subtracting two numbers, the difference is most often represented as a positive number. To ensure a positive result, put the subtracting inside the absolute value symbol. So what this is saying is sometimes when you're subtracting, you have two negative values. Then you need to think of them as being the same value, but put them in an absolute value sign so that you can find out what they equal. This works best when you're dealing with temperatures. So it says the hottest temperature ever recorded in Victoria was 36.1 degrees Celsius. The coldest temperature was -16 degrees Celsius. What is the total temperature difference? So there's two ways you can set this up. So one way would be, remember it said to ensure we have a positive result, then we're going to put the subtracting inside the absolute value sign. So I had absolute value of 36, and then we're finding out the difference in temperature, so that'd be minus that negative 16. So this is absolute value of 36 plus 16. So that gives me a value of 52 degrees. So it's a 52-degree difference between 36 degrees and minus 16 degrees. The other way to have done it is to put that negative 16 first and then minus your 36. So it's a difference of the two. So this is absolute value of negative 52, which is still 52. So if you put them inside the absolute value sign, then you're always going to get your positive result. So graphing. Now we know what the graph of a line looks like, or a linear equation. We're going to see what happens when we do an absolute value of a graph. So it says graphing absolute value functions of the form. This should say y is equal to mx plus b. So we're going to look at the example. If we graph y is equal to x, and then on the same grid, we're going to make a table of values and graph y is equal to the absolute value of x. So if we do y is equal to x, and these are the values we use, whatever my x value is, that's what my y value is going to be. So negative 3, negative 2, negative 1, 0, 1, 2, and 3. So if I go to plot those, 1, 2, 3, 1, 2, 3, so negative 3, negative 2, negative 1, 0, there's my 1, 2, 3. So it's a really nice straight line going through my origin. And this line could extend, but those are the values that I've picked. So now if I do the absolute value of that, so whatever my x is, I'm going to put it in the absolute value and get my y. So absolute value of negative 3 would be a positive 3, negative 2 would be a positive 2, negative 1 will be 1, 0 will be 0, 1 will be 1, 2 will be 2, and 3 will be 3. So nothing changes there. Now when we go to graph that one, so I'm starting at negative 3 and 3, and then I went to negative 2 and 2, negative 1 and 1, 0 was at 0, and then I had 1, 1, 2, 2, and 3, 3. So my graph for this is actually a V. So it said, how did the y values change? So the x values that were negative became positive y values in that absolute value graph. So the x values that were negative became positive y values in y is equal to absolute value of x. So the next part says, describe what is similar and what is different about the two graphs. So if we look at these graphs, where the x is equal 0 or a positive value is identical to the original graph, but the parts that were negative, where the x is negative, were just a reflection of the original graph. So the portion of the graph where x is equal to 0 positive is identical. The portion where x is negative has the y values being a mirror image or a reflection of the original. So just like in graphing, our parabolas or our quadratic functions, there is a basic count that we did. We did over 1, up 1, over 2, up 4, over 3, up 9. For absolute values of graphs of degree 1, so where your highest power is a 1, you start at the vertex, and then the basic count is go over 1 both directions, up 1, and then go over 2, up 2. And then you go over 3, up 3, and so on. So instead of being that squared like we did in quadratic functions, for the up value, we are just going by power of 1. So the general form for an absolute value graph of degree 1, y is equal to a plus or minus a. So our a can be a positive or negative value. If it's negative, then your graph is going to be going negative graphs go in this direction, positive go in that direction, right? X plus or minus p, an absolute value, plus or minus q. So same thing as in quadratic functions, the a affects if the graph is curved up, or if it's curved down. The p-value moves the graph left or right, and remember that mental switch again. So whatever the p-value is in there, you go the opposite sign. And then your q value is going to move your graph up or down. So your vertex is still going to be at PQ. Okay, so let's put this into practice. So we're going to draw a graph of y is equal to the absolute value of x minus 2 subtracting 3. We don't want to do a table of values for this one, we just want to draw it. So without making a table of values, what you want to do is you want to identify a, p, and q. So my a is a 1, my p is a positive 2, mental switch the sign, my q is negative 3. So that means my vertex for this is going to be at 2, negative 3, and my basic count is going to be up 1, over 1, up 2, over 2, and then up 3. Oh, sorry, that should be switched. It should be over and then up. So just write that the opposite. It should say over 1, up 1, over 2, up 2. So let's draw that. My vertex was at 2, negative 3. So 2, negative 3 puts me here. And then my count, my basic count, so over 1, up 1, over 1, up 1, over 2, up 2, over 2, up 2, and then over 3, up 3. Connect your dots. You should use a straight edge when you're doing that, and put arrows at the end. So that's your graph. So if I look at the domain and range of this, domain is your x values. So my x values, this graph, if I continued to go, I could have went up 10 over 10, or sorry, over 10, up 10. So I just keep going on and on and on, and I can go that in the for the negative values of x2. So my domain is a set of values for x such that x is an element of real numbers. My range, though, I never went below my negative 3. That negative 3 was the lowest point that I got to, and then everything else went up. And again, if I continued my graph, my y value would be going up. So that's the q value. So just like in quadratic functions, we looked at the q value to see what our maximum minimum point was and how that affected the range. So the range for this will be the set of values for y such that y is greater than equal to negative 3. So if a is positive, it's going to be greater than equal to. A is negative, it's going to be less than equal to. So if I graph y is equal to 4 minus 2 times the absolute value of x plus 5. Okay, I want this to be in the form y is equal to a absolute value x minus p plus q. And I didn't put the plus or minuses in because you don't need to when you're doing the general form. So what this means is my 4 is in the wrong spot. I need to move it. So this is negative 2 absolute value x plus 5 plus 4. I haven't moved it over an equal sign, so I don't change that positive 4 to a negative 4. It just stays a positive 4. So that means my a is a negative 2, so my graph is going to go down, and that a is going to affect my count. My p is negative 5, and my q is a positive 4. So that means my vertex is at negative 5 and 4. So now to do my count, it was over 1, up. Before it was up 1, but now I have to multiply by this 2. So it's not going to go up, though, because it's a negative value. It's going to be over 1, down 2, over 2, down 4, over 3, down 6. So whatever that a value is, you multiply it to your over value. So maybe I'll put a times over. Okay, so now I can plot this. My vertex was at negative 5 and 4. I can't read my numbers here. 1, 2, 3, 4. Negative 5. So it's right there. And then I do my counts. Over 1, down 2, over 1, down 2, over 2, down 4, over 2, down 4, and then over 3, down 6. So my domain again can be any value for x, but my range, because my graph is going down, I know the set of values for are going to be less than or equal to, sorry, not less than, yes, it's less than or equal to whatever my q was, -4. Okay, and the last one, I'll throw in a fraction for you. So y is equal to 1/2 x plus 1 minus 1. So it's in the proper form. I've got my a, p, q in the right order, so my a is equal to 1/2. Now remember that a value affects how wide or narrow your graph is. If a is less than 1, that means you're going to have a wide graph. If a was greater than 1, it's going to be a wider graph. Sorry, a narrower graph. My p-value is -1, and my q is also -1. So my vertex is at -1, -1. Now for my count, I'm going to go over 1, and then because a is positive, it'll go up, but I have to multiply by that half. Then it's over 2, up, so this is 2 times 1/2, so it's up 1. Over 3, up 3 times 1/2, so 3 divided by 2 is 1.5. So I do my vertex at -1 and -1, and then I do my counts. Over 1, up 1/2, over 1, up 1/2, over 2, up 1, over 2, up 1, and then over 3, up 1.5, and over 3, up 1.5. Let's pretend that went through that dot. So you can see, because my a value was less than that 1, my graph got a lot wider. In this one, my a value was, excuse me, the absolute value of a was greater than 1. It was a 2, so it made my graph narrower. So your domain for this one, a set of values for x such that x is an element of real numbers. So domain's not changing for us. Our range will, though. Set of values for y such that y is, my graph is going up, so it's greater than equal to my q value of -1. So you can work on these questions. You should have the textbook questions done for Monday, and then the worksheet we will work on Monday in class.